students, welcome to Meetu maths classes. Today's topic is from class 12 mathematics, that is NCERT chapter 11 three-dimensional geometry. And today we are going to solve some important questions of miscellaneous exercise. So let us start with our first question, that is question number 14, and it says if the point 1, 1P and another point minus 3, 0, 1 be equidistant from the plane this. You are given a plane and you are given that these 2 points are equidistant from this plane. Then find the value of P. Now there is a formula to find out the distance between a point and a plane, and that is, the formula is the distance of a point with position vector A from the plane r dot n is equals to d is मॉड्यूलस ऑफ, आप प्लेन के अंदर r को रिप्लेस करेंगे इस पॉइंट से, सो a डॉट n माइनस डी डिवाइडेड बाय द मैग्नीट्यूड ऑफ नॉर्मल वेक्टर एंड द मॉड्यूलस ऑफ दिस quantity will represent the distance between this point and this plane. So first of all, in this question we are going to find out the position vector of these 2 points. So the position vector of the point 1, 1P is, let us say A1 is equals to I plus J plus PK, okay, and the position vector of this another point minus 3, 0, 1 is, let us say A2 vector, that is minus 3I plus 0J plus K. Now according to the question, these 2 points A1 and A2 are equidistant from this plane. So according to the question, आप क्या करेंगे, डिस्टेंस बिटवीन A1 एंड गिवन प्लेन इज, A1 को आप R की जगह रिप्लेस करेंगे डॉट 3I प्लस 4J minus 12K plus 13 divided by the magnitude of normal vector, that is 3 square plus 4 square plus minus 12 का square. This is equals to the distance between A1 and this given plane is equals to the distance between A2 and the given plane. तो आप R को अपने प्लेन में रिप्लेस करेंगे A2 से डॉट 3I माइनस प्लस 4J माइनस 12K प्लस 13 डिवाइडेड बाय द मैग्नीट्यूड ऑफ नॉर्मल वेक्टर, दैट इज 3 का स्क्वायर प्लस 4 का स्क्वायर प्लस माइनस 12 का स्क्वायर. नाउ दिस विल बी द डॉट प्रोडक्ट. जब आप इनका दोनों का डॉट प्रोडक्ट लेंगे, यू विल बी this will be 1 into 3 plus 1 into 4 plus P into minus 12 plus 13 divided by square root of 9 plus 16 plus 144, and the dot product of these 2 vectors will be minus 3 into 3 plus 0 into 4 plus 1 into minus 12 plus 13 divided by magnitude of this 9 plus 16 plus 144, and this will be, this quantity is root of 169 and that is 13. So 13 can be taken out from the modulus. So this is 3 plus 4 minus 12P plus 13. Modulus of this divided by 13 is equals to modulus of minus 9 plus 0 minus 12 plus 13 divided by 13. Now this 13 can be cancelled out and you are left with, this is 7 7 plus 13 is 20 minus 12p is equals to, this will be minus 9 minus 12 is minus 17, and minus 17 plus 13 will be equals to minus 8. Okay. Now this will give you modulus of 20 minus 12p, modulus of 20 minus 12p is equals to magnitude, modulus of minus 8 is 8. Now modulus of x, modulus of using modulus of x is equals to a will implies x is equals to plus or minus a. So 20, this will implies that 20 minus 12p can be either plus or minus 8. So 20 minus 12p can be positive 8 or 20 minus 12p can be negative 8. Now this will give you 12p is equals to 12 or p is equals to 1, and this will give you 12p is equals to 28 or p is equals to 28 by 12, or we can say that (7 by 3). So p can take two values, either 1 or 7 by 3. Your next question is question number 15. Find the equation of the plane passing through the intersection of the planes. You are given two planes and the required plane must pass through the line of intersection of these two planes and parallel to x-axis. Now first of all, there is a formula to find out the equation of a plane passing through the line of intersection of two planes. So the formula is the equation of a plane through the line of intersection of two planes, r dot n1 is equals to d1 and r dot n2 is equals to d2, is r dot n1 minus d1 first plane plus lambda times second plane is equals to 0. So the equation of the required plane passing through the line of intersection of given planes is आपका क्या होगा? फर्स्ट प्लेन इज r डॉट i प्लस j प्लस k -1 plus lambda times second plane, that is r dot 2i plus 3j minus k plus 4 is equals to 0, or we can write this as r dot, your normal vector will become 1 plus 2 lambda I, then 1 plus 3 lambda j plus 1 minus lambda k, this is your normal vector, okay, is equals to, you will get this, here you will there is -1, तो right hand side पे जाके +1 हो जाएगा, and plus 4 lambda will become -4 lambda. So this is the equation of the required plane. We are supposed to find out the value of lambda here. Now we are given that the plane 1 is parallel to x-axis. We are given that plane 1 is parallel to x-axis. तो अगर एक प्लेन x-axis के parallel है, this is x-axis. If the plane is parallel to x-axis, that means normal to the plane जो भी है that is perpendicular to x-axis. Okay, that implies normal to plane 1 is perpendicular to x-axis. Now normal to the plane is this, and x-axis is another line, normal is another line. Now there is a formula that if the two lines with direction ratios a1 b1 c1 and a2 b2 c2, आपके पास दो लाइन है, एक के डायरेक्शन रेशियोज a1 b1 c1 है and another line has direction ratios a2 b2 c2, then the two lines are perpendicular if and only a1 a2 plus b1 b2 plus c1 c2 must be equals to 0. So here we are going to find out the direction ratios of normal to plane 1, and that is, let us say a1 b1 c1, and they are equals to 1 plus 2 lambda, 1 plus 3 lambda, 1 minus lambda, 1 plus 2 lambda, 1 plus 3 lambda and 1 minus lambda. And the direction ratios of x-axis is, suppose a2 b2 c2, and that is x-axis के direction ratios क्या होते हैं 1 0 0. Now the normal to the plane and x-axis are perpendicular. That implies that the product of the direction ratios 1 into 1 plus 2 lambda plus 0 into 1 plus 3 lambda plus 0 into 1 minus lambda must be equals to 0. And this will implies that 1 plus 2 lambda is equals to 0, or we can say that lambda is equals to minus half. Okay. Now substituting the value of lambda in 1, we will get the required equation of the plane. So substituting the value of lambda in 1, we will get, substituting the value of lambda in 1, we get r dot, this is 1 plus 2 lambda, lambda is minus half, I plus 1 plus 3 lambda is minus half, j plus 1 minus lambda is minus half, k is equals to 1 minus 4 lambda, 1 minus 4 lambda is minus half. So here we will get 1 minus 1, this is 0i, and here we will get 1 minus 3 by 2, that is minus half, and here we will get 1 plus half, that is 3 by 2, k is equals to, this will give you 1 plus 2, that is 3. So we can say that r dot, अगर आप ये 2 कॉमन लेके आप राइट हैंड साइड पे मल्टीप्लाई कर देते हैं, देन यू विल गेट r डॉट माइनस j प्लस 3k is equals to 6, and this is the equation of required plane. Your next question is question number 16. If O be the origin and the coordinates of P be 1, 2 and minus 3, then find the equation of the plane passing through P and perpendicular to OP. So you are required to find the equation of a plane which is passing through P and that is perpendicular to OP, and this is origin. and this is your point P, that is 1, 2 and minus 3. So there is a formula to find the equation of a plane passing through x1, y1, z1. You are given a point from which the plane is passing through and perpendicular to a line with direction ratios ABC. तो आपको इस प्लेन के ऊपर perpendicular लाइन के डायरेक्शन रेशियोज चाहिए. So first of all we are going to find the direction ratios of OP, because OP is normal vector to the plane, and that is 1 minus 0, 2 minus 0, minus 3 minus 0, that is 1, 2 and minus 3. So this is the direction ratios of normal, and the plane is passing through 1, 2 and minus 3. So the equation of plane passing through this point 1, 2, minus 3 P point and having direction ratios of normal, that is OP vector, is 1, 2 and minus 3. So this can be treated as x1, y1, z1 and this is ABC. So the required plane is 1 into x minus 1 plus 2 into x y minus 2 plus C is minus 3. So minus 3 into z minus 3 is equals to 0, and this implies x minus 1 plus 2y minus 4 minus 3z minus 9 is equals to 0, and this implies x plus 2y minus 3z, and this will give you minus 1 minus 4 is minus 5 minus 9 is minus 14 is equals to 0. So this is the required equation of the plane. Your next question is, find the equation of a plane which contains the line of intersection of the plane this and this. So you are given two planes. Your first plane is this and second plane is this, and your plane, required plane, is passing through the contains the line of intersection of these two planes and which is perpendicular to this plane. So first of all, there is a formula to find out the equation of a plane through the line of intersection of these two planes, and that is first plane plus lambda times second plane is equals to 0. So the equation of required plane passing through the line of intersection of these two planes, two given planes, is first plane, that is r dot I plus 2j plus 3k minus 4 plus lambda times second plane, that is r dot 2i plus j minus k plus 5 is equals to 0, where lambda is any scalar. Okay, now this can be written as r dot, your normal vector will become 1 plus 2 lambda I, then 2 plus lambda j plus 3 minus lambda k, this is your normal vector, and your d will become here -4 है तो वहां जाके आपका राइट हैंड साइड में it will become +4, +5 lambda, it will become -5 lambda. So this is the equation of the required plane. Now we are given that the required plane is perpendicular to this plane. The formula for the two planes to be perpendicular is two planes r dot n1 is equals to d1 and r dot n2 is equals to d2 are perpendicular if and only if the dot product of their normal vectors is equals to 0. Now according to the question, your plane 1 is perpendicular to this plane. So first of all, write down this. According to the question, your plane r dot 1 plus 2 lambda I 2 plus lambda j plus 3 minus lambda k is equals to 4 minus 5 lambda 4 minus 5 lambda. This plane is perpendicular to your given plane is r dot 5i plus 3j minus 6k plus 8. R dot 5i plus 3j minus 6k plus 3j minus 6k plus 8 is equals to 0. So these two planes are perpendicular. So the dot product, now this plane can be written as r dot 5i plus 3j minus 6k is equals to minus 8. Now to make this distance positive, we can shift negative sign in the normal vector. So the direction ratios of normal are -5, -3 and 6, and direction ratios of normal to this plane is 1 plus 2 lambda, 2 plus lambda and 3 minus lambda. So since the two planes are perpendicular, so the multiplication of their direction ratios -3 into 2 plus lambda plus 6 into 3 minus lambda must be equals to 0, and this will give you -5 minus 10 lambda minus 6 minus 3 lambda plus 18 minus 6 lambda is equals to 0, or we can say that minus 10 lambda minus 13 and minus 19 lambda minus 5 minus 6 minus 11 plus 18 is plus 7 is equals to 0. So lambda will be 7 by 19. Now substituting the value of lambda, in 1, we get the equation of the required plane. So r dot 1 plus 2 lambda is 7 by 19 I plus 2 plus lambda is 7 by 19 j plus 3 minus lambda is 7 by 19 k is equals to 4 minus 5 lambda is 7 by 19, and the required plane will become, this will be 19 plus 14, 19 plus 14 is 33 by 19i, okay, plus this is 19 to the 38 plus 7, 38 plus 7 is 45 by 19 j, and this is 19 3s are 57 minus 7, that is 50 by 19 k, okay, and 15 by 19k, and the right hand side is 19 into 4, 76 minus 3 5s are 7 5s are 35, and this will become 141 by 19. So the required equation of the plane will be 33i plus 45j plus 50k is equals to 41, and this is the equation of required plane. Your next question is question number 18. Find the distance of the point -1, -5, -10 from the point of intersection of this line. You are given a line and the plane this. You are given a line and a plane, and you are supposed to find out the distance between this point and the point of intersection of this line and plane. And to find the point of intersection, of this line, that is line 1 is r is equals to 2i minus j plus 2k plus lambda times 3i plus 4j plus 2k, and this plane, your given plane is r dot I minus j plus k is equals to 5. To find out the distance point of intersection of this line and this plane, फर्स्ट ऑफ ऑल लाइन के ऊपर आप एक जनरल पॉइंट निकाल सकते हो. लाइन 1 को आप कैसे लिख सकते हो? 2 प्लस 3 लैम्डा आई माइनस 1 प्लस 4 लैम्डा जे 2 प्लस 2 लैम्डा के. सो दिस इज अ जनरल पॉइंट ऑन लाइन 1. आप इसको प्लेन 1 में पुट कर सकते हो. सो प्लेन 1 में अगर आप इस जनरल पॉइंट को पुट करते हो, आर को रिप्लेस करते हो इस पॉइंट से, 2 प्लस 3 लैम्डा आई माइनस 1 प्लस 4 लैम्डा जे 2 प्लस 2 लैम्डा के. रिप्लेस योर आर विद दिस डॉट I minus j plus k. The dot product of these two must be 5. So 2 plus 3 lambda into 1 minus 1 plus 4 lambda into minus 1 and 2 plus 2 lambda into 1 must be equals to 5. So this will give you 2 plus 3 lambda plus 1 minus 4 lambda plus 2 lambda is equals to 5. So 3 lambda minus lambda and this is lambda. This is 2 plus 1 3, 3 plus 2 is 5. So plus 5 is equals to 5. So lambda will be equals to 0. Now substituting the value of lambda in 0, we will get a general point of intersection of this. Lambda is equals to 0 अगर आप पुट करते हैं तो point of intersection will be 2i minus j plus 2k. That implies the point of intersection is 2 minus 1 and 2. Now what we are supposed to find out? We are supposed to find out the distance between minus 1, minus 5, minus 10. So the distance between minus 1, minus 5, minus 10 and the point of intersection of line and a plane is 2 minus 1 2, 2 minus 1 2. is the required distance will be -1 -2 whole square, -5 minus -1 whole square, -10 minus 2 whole square, and this will be -3 whole square, -4 whole square, -12 whole square, and this will be 9 plus 16 plus 144, and this will give you 169, or the square root of 169 is 13. So the distance between this point, given point, and the point of intersection of this line and this plane is 13 units. So students, if you liked my videos, please subscribe my channel and press the bell icon so that you can get the notification of each my upcoming videos and you can get the benefit of it. So keep watching my videos. Have a nice day. Goodbye.